Hi, I'm Ms. Wong. Let's have a look at families of cubic polynomial functions. This looks overwhelming, but I'm just giving you a quick browse. And remember, quadratic, we needed 3 coordinates to find ABC. While for cubic, we will need 4 coordinates. And for quartic, guess what? We'll need 5 coordinates. But it's not always in the standard form. Remember in quadratics, in our previous video, we saw that it could be in the turning point form, then we only needed one more point to find the equation. Sometimes we had it in a simple turning point form at the origin, and in that case we only needed one more point to find A. Sometimes it's been translated up, so we would need 2 points to find A and C. We had x-intercept format, we had x-intercept at the origin format, and we had the standard form. So depending on what it is, we'll need different amounts of information. Let's have a look at it for cubics. So here we have one intercept, and that's it. So this is going to be an equation that looks somewhat like that. And for this one, we have the point of inflection at the origin. So it's going to be ax cubed. And depending on a, the dilation factor, it will be whatever it is. This one again, it only has one intercept, but it's also got only a point of inflection. It doesn't wiggle up and down. So this one is like that equation, but with plus k. And because it's moved to the right, we also have the h in the bracket. So that's very similar to the turning point form, but this is the point of inflection form. Here we have 3 intercepts. So what form should we use? The one with 3 brackets. And here we have a turning point and an intercept. So it looks like this, but one of the brackets will have the power of 2. So for this one, we'll be given 4 points. For this one, we'll be given only 1 point because we only have to find A. For that one, we'll be given H and K and a point. This one will be given 3 intercepts and another random point to find the dilation factor. And this one will be given the turning point and the x-intercept, and then 1 point to find the dilation factor. Notice that the turning point is also an x-intercept. Let's try this. So example 1, find the rule of this thing that has, of a cubic that has these 4 points. So 4 points, which of these would you use? If it's just 4 random points, I would use the first one. So here we have x cubed plus b squared plus cx plus d. Plug in each of them, and as I plug it in, I would get these equations. And it's a good idea to use the CAS right now and plug it all in. And then in CAS, I will show you how to do it. We would press, we'll move the calculator across, whoops. So we go to main, click on interactive and define. We're going to define a function as f of x, and the expression is, make sure that you use variable, otherwise it won't work. So ax cubed plus bx squared plus c, oops, again, make sure you click on this c, x, and then plus d. Okay. And now we go to math 1 and we look for this symbol here and we click it until we get 4 because we need 4. And now we can see and we can type in this section here, we're going to type the variables. We're looking for a, comma, b, comma, c, comma, d. And we're looking at f of 1 equals 0, f of 2, so I'm getting those values from here, equals -7, f of 4 equals 27, and f of 5 equals 80. Now I'm going to hit enter or that execute button over there, and And here we have A is 1, B is 1, C is negative 17, and D is 15. So let me screenshot that for you. So it looks like that, so that we can refer to it. So x, because it's a cubic, x cubed will have a coefficient of 1, x squared will have a coefficient of 1, x will have a coefficient negative 17, and our last value is 15. Example 2. The graph of a cubic has a point of inflection at 1, minus 3. The graph also passes through the point minus 2 and 6. Find the equation of the cubic. So we have a point of inflection over there, and it has a point into another point over there. So the point of inflection means we're using it's like the turning point format, but with a cube. So we're going to use that one there. So let's write that out. And the point of inflection is 1, negative 3, which means our K is, our H left right is 1, and our K up down is minus 3. So we write it like so. And now we can find what A is, our dilation factor, by putting negative 2 and 6. Notice that the dilation factor is just a number in front of our X bit. So it tells us how much is dilated. So minus 2 and 6, plug that in. So x is minus 2, y is 6, minus 2 minus 1 is minus 3, minus 3 cubed is negative, 3 times 3 is 9, times 3 is 27, and then we have the minus 3 over there, don't lose it, bring the minus 3 over here, we have 9, and then divided by minus 27, 9 over negative 27 is negative a third. So we have A, plug that into the equation, so the equation is minus a third x minus 1 cubed minus 3. Example 3. The graph of a cubic has an x-intercept at the origin and a turning point on the x-axis as x equals 2. The graph also passes through the point 312. Find the equation of a cubic. So here the keywords are an x-intercept at the origin and turning point. So origin, so x, and a turning point, so something squared. So we're going to use a variation of this, where b is 0 because it's going through the origin, and the turning point is the value at x equals 2, so a will be 2. So let's substitute the x-intercept at the origin, means b is 0, and the turning point is 2, so the one with the square will be 2. So let's plug that in, and now we have to find what d is by substituting the other value in, 312. So wherever you see x, we'll put 3. Wherever we see y, we'll put 12. Oh, there's a typo there, ignore that. So now we have 3 times 3 minus 2 is 1, so that's just 3. So d is 12 divided by 3, which is 4. Now we can write down the equation. The equation is y equals 4x, x minus 2 all squared. So that x is the point where it goes through the origin, and x minus 2 is the point where it is a turning point. Example 4, determine the rule to the following graph. So here we have a graph, and we can see that it's 3 intercepts. So which of the equation will we be using? So the one that has 3 intercepts is this one here. So let's use that one. So we have minus 2, 1, and 5, or in other words, x plus 2, x minus 1, and x minus 5. Now we have to find d. So there's a point there, the y-intercept, so we can use that to find d. So substitute x is 0, x is 0 and 30 for y. Plug that all in, we have 2 times minus 1 times minus 5 is 2 times positive 5 is 10. Bring the 10 over. We have 30 divided by 10 is 3. So now we have the d, chuck it in. So y equals 3, x plus 2, x minus 1, x minus 5. Here we have a few more examples. I'm not going to go through all of them. I'm going to pop the answers in a second. So pause the video, unpause when you want to see the answers to check it. Heaps of practice here. Give it a go